CBSE Class 10 Math, Chapter 5 Revision, Arithmetic Progressions. This again is an important topic. I've seen question papers from 2016, board papers as well as sample question papers. You get a minimum of one question from this chapter. You could get anything from 2 to 3 questions. How many marks do they typically come from? It comes in all variants. I've seen 1 mark questions, 2, 3, 4. All variants of questions have come from this chapter. In addition to the definition of what this arithmetic progression is, the two important concepts which are tested are basically this. Finding the nth term of an arithmetic progression and finding the sum up to n terms. Only two concepts. There are formulae for each of these things. Once you know the formula as to how to compute the n term and the formulas to compute the sum up to n terms, we've done with this topic. We have lined it up with 8 questions, lookalikes of questions that have appeared in the past board papers. And as always, I've given you a listing of questions that have appeared in the past board papers. If you log into online.maxtute.com, we've got solutions for each of those board papers given as part of the revision chapter. Right? Let's get started. Let's start with the first one, which is definition of an arithmetic progression. An arithmetic progression is just a list of numbers which satisfies this property, in which each term is obtained by adding a fixed number to the preceding term except the first term. Obviously, the first term does not have a preceding term. Let's take a very simple example. Let's say the first term is a 3. I'm adding a 5 to get the second term. So the next term is going to be 8. I'll add a 5 to get the third term, which is a 13. Add a 5 to get the fourth term, which is equal to 18. So second term was obtained by adding 5 to the first term. Third term was obtained by adding 5 to the second term, so on and so forth. This term that we are adding, this fixed number that we are adding, is called the common difference of the arithmetic progression. In this example, the common difference is equal to 5. The common difference can be a positive number, can be an integer, can be a non-integer, can be a negative number, can also be 0. For example, 5, 5, 5. These three numbers are in an AP where the common difference is equal to 0. So common difference can very well be 0. Now, what is the general form of an AP? The first term, let's say, is A. The common difference we said is represented by this letter D. The second term is adding one common difference to the first term. Now, I add one more common difference to it, I'll get the third term. So it's A plus D, which is A plus 2D. The fourth term is going to be A plus 3D. So next comes the second concept, which is finding out the nth term of an arithmetic progression. The nth term is obtained by adding n minus 1 common differences to the first term. So an equals a plus n minus 1 times d. So this is the defining formula for this entire progression. Let's solve a few questions as to how this idea is tested in the board exam. And then look at the third concept, which is sum up to n terms. Let's look at the first question. We need to find out the common difference of an AP in which the data given to us is that A18 minus A3 is equal to 75. The difference between the 18th term and the third term is a 75. Let's apply the standard formula, which is AN is equal to A plus n minus 1 times the common difference. We need to find out what the common difference is. So A18 is going to be equal to A, which is the first term, plus 18 minus 1, which is 17 times common difference. This minus the third term, A3, will be nothing but A plus n minus 1 times here will be 3 minus 1, which is 2D. So A18 is A plus 17D, A3 is A plus 2D. They're saying this difference is equal to 75. Let's find out what this difference is. A minus A will get cancelled. 17D minus 2D will leave us with 15D. This is equal to 75. So D is equal to 5. So the common difference of this progression is 5. Quickly run through it in a printed form and summarize it as you go about it. The third term is equal to A plus 2D, A plus 3 minus 1 into D. 18th term is equal to A plus 17D. Given data is A18 minus A3 equals 75. A18 is A plus 17D. A3 is A plus 2D. So A and A gets cancelled. 17D minus 2D is 15D. 15D is 75. D is equal to 5. Right? Very simple question. Would have been a 1 mark question whenever it was tested. Quickly look at one more example. For what value of n are the nth terms of two APs? Right? We've been given this is one arithmetic progression. This is a second arithmetic progression. The nth term of this progression, the value of that, let's say the nth term is 140. The nth term of this one should also be 140. So we'll have to find out what is that term. Is it the 10th term? Is it the 12th term? Is it the 90th term? We'll have to find out what is the value of n. We'll get started. Say we'll quickly jot down key data for the first progression. Key data for the first progression is the first term is a 72. Common difference is the difference between any two consecutive terms, which in this case is equal to 4. We know that the nth term of this progression is equal to the nth term of this progression. So we'll write down the formula for the nth term for this progression. The nth term is an equals a plus n minus 1 into d1. I'm calling it d1 because we have two different progressions. This is a common difference of the first progression. So the nth term of this progression is equal to the first term, which is equal to 72 plus n we do not know, n minus 1 times the common difference in this case is equal to 4. So let's expand this term, which is equal to 72 plus 4n minus 4. This will translate to 68 plus 4n. So the nth term of the first progression is 68 plus 4n. Let's quickly run through the same process for the second one. Here I'm calling the first term to be a b, so there is no confusion between this a and b. Let's say the common difference here is d2, which is the difference between any two consecutive terms, which is equal to 8. So let's compute the nth term of this progression. Let's call it as bn. So bn is equal to the first term, which is equal to 4 plus n minus 1 times. The n is going to be the same here. We're trying to compute the value of that value of n, which is going to be that term which is common to both. So 4 plus n minus 1 into d2. d2 is equal to 8. Let's expand this. This is going to be 4 plus 8n minus 8. So this is going to become 8n minus 4. The question is mentioning that the nth term of the first progression is equal to the nth term of the second progression, which means that the nth term here, which is a 68 plus 4n, is equal to 8n minus 4. Take the n terms to one side, you will get 4n. Take the minus 4 to the left hand side, you're going to get 72. 4n equals 72. The value of n is equal to 72 by 4, which is equal to 18. The 18th term of this progression and the 18th term of this progression will have the same value. Quickly run through this in a printed form. The nth term of this progression is the first term plus n minus 1 times the common difference. So this will basically boil down to 68 plus 4n. Second progression, bn is equal to the first term here is a 4 plus n minus 1 times the common difference, which is equal to 8. This simplifies as bn is equal to 8n minus 4. The question mentions an equals bn. Find that value of n for which an will be equal to bn, which is 68 plus 4n should be equal to 8n minus 4, leaving us with the value of n to be equal to 18. Right? It's probably a 3-mark question. It's a little more difficult because you have to find out, you have to understand what this question says and then translate it into equations, solve it and get the answer. Let's move on. Find the 10th term from the last term, not from the first term of this AP. First things about this AP, the common difference is equal to 4. See, the typical formula for an arithmetic progression is for nth term is the first term plus n minus 1 times the common difference. So you're always looking at the nth term from the first term. This is asking you, for example, let's say the mth term from the last term. The last term is a 245. What do you think is the term preceding that? There will be one common difference less than that. So that's going to be, I'm going to write down the term before that. This is 241. The term before that is going to be 237. Let's stop here. So the last term, 245, we'll call it as an, that is 245. The second last term is going to be one common difference, an minus d. The third last term is equal to the last term minus two common differences. What are we trying to find out? We are trying to find out the 10th term from the last term. So the 10th term from the last term, I'll say 10th from last. 10th from last will therefore be equal to the nth term, an, minus, to get the second last term, we subtracted one common difference. Third last term, we subtracted two common differences. To get the 10th last term, we have to subtract 9 common differences from the last term. What is the last term? That's equal to 245. What is the common difference? We computed it to be a 4. So 9 times 4. So that is 245 minus 36, which is equal to 209. Right? That's all it takes. The typical formula is from the first, we'll be adding. Because we're coming from the last, we need to subtract so many common differences. Summarize it in a printed form. First term, last term given to us. Common difference is difference between any two terms, which is equal to a 4. Formula for the nth term is this when you're going from the first term. If you're arriving it from the last term, if you have to find out the mth term from the last term, that is going to be equal to the last term. You'll have to subtract m minus 1 common differences from it. What is the last term? 245. What are we trying to find out? The 10th term from the last term. So m becomes 10. 245 minus 10 minus 1 times the common difference, which is 4, giving us an answer which is equal to 209. This concept of the nth term has been tested in so many papers with so many questions. Sometimes you have 3 questions from a single paper, 3 questions here again. All of these questions, we have solved them and we have listed those questions with videos just beneath the revision for each of these chapters. So go to the revision for arithmetic progression After this video, you'll have the questions that have appeared in the past board papers and sample question papers. So you can quickly run through that, solve them initially, and if you have any issues, go through the videos to understand how it is solved. Let's move to the next concept, which is sum up to first n terms of an AP. The two formulae to compute that. Both these formulae will give us the same answer. We'll use one or the other formula depending upon what data is given to us. The first formula is sum up to n terms is n by 2 into 2a plus n minus 1 into d, where a is the first term, n is the number of terms up to which you are finding out the sum, and d is the common difference. Another way of computing it is basically n by 2 into a plus an. This is nothing but, look at this. This 2a, I'll write it as a plus n minus 1 into d. This is nothing but an. So it's the same formula written a little differently. So in this case, sum up to n terms is n by 2 into a plus an. If you know the first and last term, go with this. If you know the first term and the common difference, go with this. Let's get started with a few examples to consolidate this idea. Find the sum of the first 15 multiples of 7. Let's just list down these multiples of 7. I'm going to start, the first multiple is 7, then it is 14, then it is 21. Let's not list all of them. Let's go to the 15th multiple, which is equal to 105. So starting with 7, you're going to go all the way up to 105. We need to find the sum of all of these numbers. First things, the difference between these two terms is a 7. Difference between these two is a 7. Last term is 105. The last but one would be 98. So difference is going to be a 7. So the difference between any two consecutive terms is a 7. If the next term is obtained by adding a fixed number to the preceding term, obviously we are talking about an AP. What all do we have in this AP? We know the first term of this AP. We know the last term of this AP. We know the number of terms in this AP. So if we need to find out the sum up to 15 terms, all we are going to do is basically substitute this formula. I'll start the formula with Sn, which is n by 2 into a plus an. N is equal to 15. So let's find out the sum of the first 15 terms, which is S15 equals 15 by 2 into the first term, which is 7, plus the last term, which is equal to 105. So this is 15 by 2 into 7 plus 105 is a 112. Cancels with the 2 to leave us with 56. 56 into 15, 56 into 10 is a 560, 56 into 5 is a 280, 560 plus 280 is equal to 840. So sum of the first 15 multiples of 7 is equal to 840. Summarize it again in a printed form. These are the first 15 multiples of 7. They are in an AP, obviously. The second term is obtained by adding a 7 to the first one, 7 to the second term will give us a third term, and so on. What is the first term of this AP? 7. Last term is 105. Common difference is 7. Number of terms is equal to 15. Sum of these is given by this formula. We know the first term, we know the last term, and the number of terms. Plug in all of these. 15 by 2, first term plus last term, gives us an answer 840. Sum of the first 15 multiples of 7 is 840. Look at the next example in this fifth question in this series. How many terms of an AP 4, 13, 22 must be taken to get a sum of 754? Given us the sum, they've told us what the AP is in some way. The first term is equal to 4. The common difference is the difference between these two. The common difference is 13 minus 4, which is equal to 9. So we know the common difference. We know the first term. We know the sum. What we need to find out is basically what is n. So plug it into the formula and check out if we have everything that is there other than n. So this is the AP that is given to us. First term, common difference computed. Sum is given. Formula to compute the sum is n by 2 into 2a plus n minus 1 into d. Do we know n? That's what we are trying to find out. A is given, which is 4. D is given, which is equal to 9. So it becomes a one equation, one variable. Just frame the equation, solve it, get the answer. Solving the equation tends to get a little tedious in this case. So let's go over it. Let's run through the process. So the sum up to n terms is 754. This is equal to n by 2 into 2 times a, which is 2 times 4, plus n minus 1 times the common difference, which is equal to 9. Let's cross multiply this 2. So 1500 plus 8, which is 1508, is equal to n times. This is an 8 plus 9n minus 9. That's what we have. 8 minus 9 is a minus 1. So if I rewrite this, is going to be 1508 is equal to 8 minus 9 is a minus 1 into n, which is a minus n. And then we have n into 9n, which is equal to 9n square. Let's take all terms to one side. We'll get 9n square minus n. The 1508 comes to the right hand side as minus 1508 equals 0. Wow, we have a quadratic equation. But it's not a very friendly equation. The product of the first and the last term is 9 times 1508. If you're trying to use either the quadratic formula or the factorization method, both are going to be tedious in this case, because you're going to find out the square of 1 and you're going to add with 4 into a into c. Anyway, you'll have to find out this product of these two numbers. Let's get started with it. This is a factorizable number, so let's do it. So 1508 into 9. 1500 into 9 is 13,500. 8 into 9 is 72. So 9 times 1508, the product of the first and the last term, is 13,572. Right? The first difficulty is done. Now we need to break this number. We have a minus 1, b is equal to minus 1. That has to be broken down into two parts, such that the product of those two parts is 13,572. The difference is just 1, which means we are talking about two consecutive numbers. Now let's use some help, whatever we know. 100 into 100 is a 10,000, right? I'm just going to do some bits here to help us go. 100 into 100. Two consecutive numbers we need, but I'm just looking at two same numbers. Then we'll figure out consecutive. This is a 10,000. So obviously, if the product is 13,572, both these values will have to be greater than 100. I'll go one step further. 12 12s are 144. So 120 into 120 is 14,400. We have a 13,572. So definitely both these numbers, which are consecutive numbers because the difference is just 1, will have to be less than 120. It ends in a 2. What all can end in a 2? 6 times 7 will end in a 2. 8 times 9 will end in a 2. 3 times 4 will end in a 2. Consecutive numbers that should end in a 2. Let's pick the middle number. Let's see if this value is greater, we'll go with this. If this value is lesser, we'll go with this. So this middle number helps us get that gauge. So if the number had been 116 and 117, the difference will be 1. Let's see what the product of that is. Right? I'm going to take this space to do that calculation. 116 times 117. 6 sevens are 42, 4 carried over, 7 plus 4, 11, 1 carried over, 7 in plus 1, which is 8. The remaining two are quite easy to write. It's 116 here, and then we have a 6, 1, 1 here. So this is 2, this number is a 7, 8 plus 1, 9, 9 plus 6 is 5, carried over 15, which is a carried over 1, which is a 3. Wow, we got the answer with this one. We struck gold in this first iteration. So 116 into 117 will give us the answer. 9n square minus 117n plus 116n minus 1508 equals 0. The sum of these digits is 9. So this number is divisible by 9. Let's take a 9n common from both. So it leaves us with n minus 13. 13 nines are 117. 116 will divide this number 13 times. So this is 116 taken out will leave us with n minus 13. You can verify this if you want. This is equal to 0. So we have n minus 13 times 9n plus 116 is equal to 0. If n minus 13 is a 0, n is equal to 13. If 9n plus 116 is a 0, then n is equal to minus 116 upon 9. What is n? n is the number of terms. Can the number of terms ever be a fraction, let alone being a negative fraction? So minus 116 by 9 is ruled out. Number of terms is equal to 13. So you need to add 13 terms of the sequence to get the answer as 754. The sum is 754. Quickly run through this entire thing in a printed form. We have plugged in the value of Sn in the next step as 754, A as 4, D is equal to 9, and then cross multiply it, which will leave us with a 1508, and this term 8 minus 9 becomes a minus 1, this is a 9n, resulting in this quadratic equation. The product of 9 and 1508 is equal to 13,572. We are splitting the middle term as minus 117 and plus 116, resulting in the factorization giving us a value of n to be 13 and a negative fraction, which is not possible. So we'll have to take 13 terms of this progression to get a sum of 754. This factorization bit makes this question a tough question. So move on to the next one. Sum of the first 10 terms of an AP is equal to 295. So we know S10. The first term is given. We need to find out the 15th term. Let's get started. Key data is first term, sum up to first terms. Then we have the formula, typical formula, which is n by 2 into 2a plus n minus 1 into d. Let's plug in whatever we have. The first step, we're going to find out the common difference, right? So we take Sn, which is equal to 295. N is equal to 10 because it is the sum of the first 10 terms. 10 by 2 into 2a, which is 2 times 7, plus n minus 1, which is 10 minus 1, I'll write it as a 9, times common difference. So we have one equation, one variable. We solve the equation, get the value for d. 10 by 2 is a 5. Divide both sides of the equation by a 5. Left hand side becomes 59. The 5 will get cancelled. And then we'll be left with 14 plus 9d. Take the 14 to the left hand side. 45 is equal to 9d, which means d is equal to 45 by 9, which is equal to 5. So step 1, we have computed the common difference. Step 2, we're going to find out the 15th term. 15th term A15 is equal to the first term. Do you know the value? Yes, that's a 7. Plus n minus 1, which is 15 minus 1, common difference, which is equal to 5. Let's plug in both those values. So 7 plus 14 times the common difference, which is equal to 5. 14 5s are 70. 70 plus 7 is equal to 77. So 15th term is equal to 77. Quickly run through both these parts in a printed form. Take an S10 as 295. 10 by 2 is a 5. 14 plus 9d. Divide both sides by 5. We'll get a 59 on the left hand side, and the right hand side will just be this expression. Take 14 to the left hand side. 45 equals 90. D is equal to 5. We're going to plug that in into this formula. We know the value of A, which is a 7. We found out the common difference to be a 5. We're trying to find out the 15th term, so it's 15 minus 1, resulting in the value of the 15th term being 77. Next question. The first term of an AP is 4. Last term is given. You know the first term, we know the last term. The sum of all of these terms is 129. What we need to find out is n. We need to find out the common difference. Let's get started. Sum is given, first term is given, last term is given. So let's go with the first term, last term, and compute the number of terms. Sum is equal to 129. This is equal to, we're trying to find out the value of n. First term is equal to 4. Last term is equal to 39. Cross multiply, you'll get 129 into 2. That's equal to 258. This is equal to n times 4 plus 39 is a 43. Divide both sides by a 43. If I divide 258 by a 43, it's equal to 6. And the right hand side is going to be an n. So number of terms which you'll have to find out, we have computed it to be a 6. Subsequently, let's find out the common difference. We know the nth term, the last term is 39. This is equal to, the first term is 4. We are trying to find out the common difference. How many terms do we have? We have 6 terms. So n minus 1 is the 6 minus 1 times d. Take the 4 to the left hand side, that will leave us with a 35. This is equal to 5d. 35 equals 5d. D is equal to 35 by 5, which is equal to 7. Common difference is 7. Number of terms is equal to 6. Right? Plugging in the value of Sn as 129. First term, last term. Finding out the value of n to be a 6. Plugging that value into an equals a1 plus n minus 1 into d. 39. The first term is a 4. We found out the number of terms to be a 6. We realize that the common difference is equal to 7. The last question, it's a lovely question, is going to help us understand some very core idea about how to look at a set of terms in an AP. The sum of 4 consecutive numbers in an AP is 24. And the ratio of the product of the first and the last term. So we have 1, 2, 3, 4 terms. A1, A2, A3, A4. They're saying the ratio of the product of the first and the last to that of the product of the middle 2 terms is 27 is to 35. We need to find out what are these 4 numbers. Whenever they say there are 4 numbers in an AP, 4 consecutive terms in an AP, take those terms as follows. A minus 3D, A minus D, A plus D, and A plus 3D. Right? I'll tell you why we are doing it in a while. Note one thing, the first term is not A. In fact, A is not any of the terms at all. The first term is actually A minus 3D. What did we add to A minus 3D to get the next term? A minus 3D. And the next term is a minus d. The difference between these two is actually 2d. So the common difference of this progression is equal to 2d. So the usual denotations that we have, a and d, are not the same in this particular case. If you have 4 terms, go with this. In some cases, they might say, we have 3 terms in an AP. In that case, go with a minus d, a, and a plus d as the 3 terms. In this case, again, the first term is not a. The first term is a minus d. But the common difference in this case is equal to a d. What is the rationale for doing this? When I expand this first statement and we write it as an equation, it will be very clear. So 4 terms in an AP, we are taking them as follows. We know that the sum of the first 4 terms is equal to 24. So let's add all of these, right? There will be a minus 3d plus a minus d, which is the second term, plus a plus d, which is the third term, plus a plus 3d. The sum of these 4 terms is equal to a 24. The minus 3d and a plus 3d gets cancelled. Minus d and plus d will get cancelled. What is the left hand side left out with? We are left with just a plus a plus a plus a, which is 4a equals 24, which means a is equal to 6. The advantage of writing it this way is the moment we added it, we reduced it from a 2 variable equation to just a 1 variable equation and found out the answer for one of the variables. Again, note very clearly, a is not any term in this sequence. The first term is not a, the first term is actually a minus 3d. Now let's take the second information. It says a ratio of the product of the first and the last term. The product of the first and the last term is a minus 3d times a plus 3d. This is the product of the first and last term. The ratio of this to the product of the middle two terms. The product of the middle two terms are a minus d times a plus d. This ratio is equal to 27 by 35 is what the question says. One thing, we can plug in the value of a as 6 right away, or you can plug it in later. We'll plug it in later. Let's do it in the last but one step. So the numerator will become a square minus 9d square. Cross multiply the 35 with it in this step. So 35 into a square minus 9d square. This is equal to 27, and cross multiplying this term after multiplying it will be a square minus d square. Expand both sides, so we'll be left with 35a square minus 315d square. This is equal to 27a square minus 27d square. Take all a square term to one side. So 35, just drawing a line to make it clear. 35a square minus 27a square will leave us with 8a square. On the right hand side, the 315 goes to the right hand side. 315 minus 27 is a 288. 288d square is what we have. Divide both sides by 8. So a square is equal to a 36d square. What did we find the value of a as? We found the value of a to be a 6. Plug it in here. 6 square is equal to 36d square. Divide both sides by 36. So we'll have 1 equals d square, which means d is equal to plus or minus 1. Let's compute the term. D is a plus or minus 1. If d is equal to 1, what will be the term? A is a 6. 6 minus 3 into 1, which is equal to a 3. That's the first term. 6 minus d, which is 6 minus 1, 6 plus 1, and 6 plus 3. These will be the terms. So 3, 5, 7, 9. What if d is equal to minus 1? D is a minus 1. It's going to be 6 minus 3d. 6 minus 3 into minus 1. That's going to be 6 minus of minus 3, which is a 9. And then the next term is going to be 6 minus d, which is 6 minus of minus 1, which is going to be 6 plus 1, which is a 7. Next one is a plus d, which is 6 plus d is a 6 minus 1, which is equal to 5. 6 minus 3d, which is 6 minus 3, which is equal to a 3. So terms are either 3579 or 9753, depending upon whether d is 1 or d is minus 1. Quickly summarize it, the entire thing in a printed form. Adding these four numbers, the 3d's and d's get cancelled to get the value of a to be a 6. Next part is the ratio. Product of the first and the last term, and the ratio of that to the product of the middle two terms is 27 by 35. Cross multiplying and expanding it, 35 into a square minus 9d square is 27 into a square minus d square. Take all a square terms to one side, you get 8a square, and all the d square terms to one side, 288d square. Divide by 8, we get a square equals 36d square. Plug in a as 6, get the value of d to be equal to plus or minus 1. If d is a 1, we know a is equal to 6. The four terms are these, 3, 5, 7, 9. If d is equal to minus 1, we know a is equal to 6. Substitute that here. The four terms are 9, 7, 5, 3. This will be an ascending AP if the common difference is positive. The common difference here is negative, therefore it's a descending AP. So exactly two concepts, the nth term, sum up to n terms. Very, very easy topic to get answers right? So we get a question in arithmetic progression, you necessarily will have to get it right. These are all the questions that were tested. We've given video solutions to all of these questions, and they are available in the online.maxtute.com portal. Visit the portal, 10th standard, sign up into it, and then get going to the revision course. The revision course, beneath each chapter for revision, we've given videos and slide packs for the questions that are tested from 2016 from that chapter. Best wishes. Before you leave, do two things. Sign up at online.maxtute.com for CBSE online coaching for class 10 maths. Takes less than 5 minutes in all of 3 steps to get started. And do one more thing. Subscribe to this channel, youtube.com/maxtute, and spread the word about this channel to your friends and classmates.